Security first. Good. Can you hear me well? They're back as well? Okay. Web application security, we all talk and we all know about that. All of the applications are now accessible over web. I still remember when I developed my first web application, it was in the late 90s, actually, to solve all of the paperwork for a distribution firm like Aleph. During that times, I developed it even in PHP 2, if some of you still remember. And then I got a question from everybody why I develop it as a web application and not as a classical client server. And they have told me that such a thing will never be used in the world in the coming years. Now the situation has completely changed. All of the applications are over web, as I have mentioned. Even for this application, I was responsible for the Unix servers as well, and I want to have them as secure as possible, of course. So I tried to break through the Unix server and the web application. I was surprised how easy it was. So what I was being able to do on my application, I then tried on the internet with really a lot of success. Security during that days was not based on the applications or not based on the services itself. We, of course, want to protect our data. Firewalls, they have only started then. Now we got used to them. On our desktops, we all have antivirus, anti-spam, anti-whatever. We secure the operating systems where the complete system runs. We started to get used to the intrusion prevention and intrusion detection systems. But what about the web application? Now I mean the web application itself. Is the web application somehow secure? I have an answer for you. It's not. Because there is an excellent firewall on the perimeter. But when we want to make the application to be accessible from the outside, we need to make a hole into it for port 80 and 443, HTTP, HTTPS. But in this case, the application, I repeat it, the web application itself is accessible from the outside, like if there were no firewall. This can be for different reasons. Well, why are the web applications vulnerable? If we talk about a real web application where a team does a development, can a team or can coding solve the security as well? Some kind of. What we require from a web application developers? Why do we use or why do we develop the web application? First of all, to give the service to our customers, which is functionality, stability, performance. Does the business require from the developers the security? It does not. It's all of the other functionality. Security is not the main focus there. That's why we require a different approach how to make the web application secure. First of all, during the coding or during the development, there are best practice design methods. There is ISO standards which have to be followed during web application development. But does every team member focus on security? Does every team member write every line of a code with focus to security? Not at all. I was part of a web development team, and security was the last, for obvious reasons, for business reasons. And what if the application is developed by a third party? How can we influence the web development process of a third party? Very hard, if we even have some possibilities. So we have the web application ready, developed securely. Another best practice is to run penetration tests or to do some testing. There is a lot of firms, there is a lot of companies, there even is a cloud service which can do the penetration testing for you. But can we rely on the results of the penetration tests? We can't. Result, you know it as well, that result of every test is only as good as the test itself is. That's why, last but not least, there is the web application firewall. I am not saying that the web application, that if you buy a web application firewall and you implement it well in your infrastructure, that you are completely done. Of course, only a combination of all of these methods can give you a complete protection. But the web application firewall has, first of all, a financial advantage. Let's imagine there is no web application firewall, and the penetration tests have discovered some security holes. What is the only way how we can fix it? To get back again to the development team, to show them the holes, to teach them how to fix them, and then do the complete process all around again. I don't think using this traditional approach it can be solved within days. I would say weeks. How much does a week of web application development team cost? Could be around $50,000. This is my guess. But if the web application firewall is already there, and during penetration tests or during whatever operation we have discovered there is a security hole, with the web application firewall we already have the protection. It can be fixed within minutes with almost zero additional cost. That's the biggest advantage of a web application firewall. Web application firewall can be shared within different services, for different applications. Even for different customers, if you offer the applications for a wider area of them. What we want to solve and what we want to protect, it's as excellent described on internet where the OWASP Open Web Application Security Project lives. I have the list from January 2007, but there is only one or in the last days 2 changes. That's why I have even kept the old one, because the security world hasn't changed so much in terms of classical web application hacking. It's still the same vulnerabilities. It's still the same methods. Everybody knows about them. OWASP categorizes all of the web application vulnerabilities, describes them. Unfortunately, you will not find any manual there which will show you how to exploit it or how to do the hack. I can show you if we have some time left. But it's all described there. And my question is, would you use a device which does not give you a complete protection? Only a specialized device, a specialized web application firewall gives you a complete protection against all of the vulnerabilities or all of the attacks which exist or which can be exploited. There is some protection implemented on the network firewalls. There is some protection implemented on the IPSs, IDSs, but definitely not a complete one. Attacks for or protection from the common attacks can be done with these traditional devices as well. For instance, forceful browsing is an attack to the logic of the application. Hidden field manipulation, parameter tampering, cookie poisoning as well. That's why I say that the web application firewall operates on the 8th layer of the OC model, even though OC, of course, has only 7. And that's the logic of the application. An example of a forceful browsing attack is even my 14-year-old daughter. Last year before Christmas, she wanted to buy some CDs, so I told her order them on an online shop and then I will come with the credit card, pay for it. This is what we did. And then she told me that she has forgotten to add additional 2 CDs. So I told her, okay, so make another order and then call me and I will pay for again. If she didn't call me for half an hour, I came to her and asked her, what's with your 2 additional CDs? And she told me, it's done. I got it, done? And she said, yes, I have added to the order and the system has accepted. So I asked him, and how did you pay for? And she told me, oops, I didn't. And really the order came with 2 additional CDs, which we didn't have to pay for. And she did it very logically. After the payment in the browser history, she went to the last page of the shopping basket, where from you have 2 options. Either proceed to checkout or continue shopping. She clicked continue shopping. She added the additional 2 CDs to it, and then she clicked again, proceed to checkout. The session didn't expire yet, but was already marked as paid. Easy. Don't ask me about the name of the online shop. I will not tell you. It's still vulnerable to it. But that's an example of a forceful browsing attack, that you enforce access to a certain page or you enforce calling of a certain script. Another example could be, again, an online shop. You would like to purchase an item and the application says, all right, this item costs 125 euro. It's really easy to change it to €1. By the way, this is how Amazon or eBay works. And you will get that item for €1. Somebody would say, this is a badly written application. Well, I say it's an excellent written application, but not because of security, but because of performance. Let's imagine Amazon, eBay. Millions of concurrent users every hour. That's millions of requests. If the application stored only item ID on the client side, and the price should be then get from a database, I don't think such a database exists on this planet. So from a performance point of view, it's an excellent written application. From a security point of view, it's, of course, piece of a you-know-what. But why I'm telling that, are the traditional devices like network firewalls, even though the vendor claims that there is a web protection, or any intrusion prevention system, intrusion detection system, even though the vendor claims there is a web protection, are these devices able to discover, for instance, this price change or this forceful browsing? When they check the referrer header can be always spoofed. Only a specialized device, only a web application firewall can give you a complete protection, and it's because of the security model which is used. Traditional devices, they use only negative security model. Negative security model says everything is allowed except for what is denied. And denial occurs using signatures. Signature is a regular expression for pattern matching string. Are you able to write an expression which will discover this price change or forceful browsing? When we talk about price change, we talk about hidden field manipulation or parameter tampering. This is impossible. You can't. That's why negative and positive security model gives you the complete protection. Positive security model says everything is denied except for what is allowed. So you explicitly allow only legitimate requests to go through the web application firewall. We say that you teach the web application firewall so-called good behavior of an application. Anything which will be not 100% compatible with this definition of a good behavior will be considered as an attack and can be blocked. I can go technically deeper in it. This is an example of an application flow. Application flow light can be used, for instance, to bypass a login page. With the web application firewall, you can define this. These sites or these scripts can be accessed only after a successful login, where the web application firewall can even check for whether the login was successful or not. And with the definition, we can go, and this is exactly the 8th layer, the logic of the application. You define which URLs are allowed, which parameters are allowed, what are the parameter values allowed, again, even in a combination with a certain flow. And it depends on the level of your paranoia, how deeply you want to go. Some parts of the application require to check for URLs. Some parts even for the parameter values. In some parts, we need to include the flow as well. Policy shouldn't go to the very little detail for the complete application. And good news is you don't have to define it all by hand. There is policy building tools. In ideal world, first of all, you define your level of paranoia, or how tight the security policy has to be, and you switch the learning mode on, and then you do UAT through our web application firewall, which is called Application Security Manager. Then Application Security Manager will remember all of the communication and with one mouse click will build a security policy automatically, which will allow only this communication. I know it's in ideal world. In during UAT, user acceptance tests, you want to check every page. You want to check every combination of possible values, parameters, scripts, etc., etc. That's why we do recommend it during UAT. Afterwards, of course, it can be then changed manually. Another option could be that there is, for the commercially mostly used applications, there is templates, like for Lotus Domino, SharePoint, Outlook, Web Access, PeopleSoft, and so on and so on. So we have a predefined templates for it. The templates, they don't give you 100% protection because every deployment of every SharePoint, for instance, is different, but you can still adjust. Or we have cooperation with vulnerability assessment tools, Whitehat, Senzik, the mostly used ones. I personally use the Senzik, or like the Senzik most, because Senzik GUI is implemented into ASM GUI. So there is a company which does the vulnerability assessment for you, not only using automated tools, but there is live hackers. And as the result, you get report where it will be detailed described what kind of vulnerabilities have been found. So this can go to the management, but immediately usable application security manager policy as well, which will cover only these vulnerabilities. It's called virtual patching. So you have both. And with the Senzik, don't tell anybody, but with one application, you even have it for free. We have discussed that. Is there any questions regarding what I have mentioned so far? Don't hesitate to ask. All right. I don't know whether it was in the news here in Hungary, but Czech Republic has undergone 5 weeks ago a huge DOS attack. Basically, all of the applications, all of the services like web portals, media, even internet banking was heavily attacked by a botnet denial of service attack with a lot of success. I have done a research that how to bring all of the internet bankings in Czech Republic down, how much time it would take and how much money it would cost. And it's 15 minutes and $2,000. It's really very, very easy. Botnets, you can Google them out, and a huge list will appear, different tools how to do a layer 7 denial of service attack. GUI for you is available immediately. You have to only specify the victim and pay. You can pay doing bank transaction, credit card, even PayPal. PayPal is totally anonymous, which has nothing to do with the anonymous group. So the world has changed. Application Security Manager contains protection against layer 7 DOS and DDoS attacks as well. Denial of service. You make such a request which will force the application engine to stop working. An example could be, let's imagine search engine. a star-based search, if there is star in the search string, has much higher impact to the search engine if we talk about performance. But it still is a valid HTTP request. We, of course, want to allow stars to be in the search string. On the network layer, it doesn't show any anomaly. So if an attacker can construct a query which will have a lot of impact to the application engine, and the application engine will crash. On Application Security Manager, we measure the average application response latency, how fast or how quick the application can respond to user requests. If we recognize that the latency grows, which means that somebody is harming the application, then we will start to measure how many transactions per second is there made. And if it then reaches certain limit, we can either completely stop this communication or apply a RAID limit on both sides to only this particular URL which is attacked to make the rest of the application work, and only to the attacker. That's for layer 7, denial of service attack. The attacks from Czech Republic, they were made using botnets. There is a botnet protection implemented on Application Security Manager as well. We detect a human activity behind a request. JavaScript reacts on mouse movements or on keys or on keystrokes or on a behavior which is done only by a human, not by an automated tool. We have successfully used it for EasyJet and Ryanair, but for a different purpose. Expedia used a botnet to read the content of Ryanair and EasyJet to get the timetable and the actual prices. They added 15 or 20% on top of it and sold Ryanair and EasyJet flight tickets with this additional price. Ryanair, EasyJet, they tried to block the IP addresses, do lawful stuff, took them to the court. Nothing helped. With our solution, the botnet has been automatically detected. And really, Ryanair and EasyJet, they immediately bought it just for that purpose. Additional to it, cross-site request forgery, very known attack. Protection is implemented there. We have antivirus support. The antivirus engine is not included on our box. We use an external antivirus, and the communication is used using the ICAP protocol. There is complete web services security, if we talk SOAP, XML, Web 2.0. There is support for the encryption. Complete message can be encrypted and decrypted, or only certain values within certain tags, or together with the certain tags, or the message can be signed or checked for, or the signature can be checked with a full XML firewall to protect the XML functionality on the 8th layer as well. And we have IP penalties and IP enforcement. IP penalties mean that if there is X violations during Y amount of time, then the IP address will be blocked. And in the newest release, we have acquired an IP reputation blacklist database where based on this reputation, the requests can be blocked. And that's the complete security which can be achieved with Application Security Manager. I hope I have told you some interesting stuff. Should you have any questions, please go ahead. If you want to see it in action, please contact Aleph, and we can come to your company or to your customer together with a technician, and we can deploy and install it there, so you will see by yourself how complicated or how easy is to set up a web application firewall to get a complete web application protection. Thank you very much for your time.